In this lesson, we're going to be adding our first sound effect in our game. This sound will be our first 3D sound of our game, so we're going to do a little bit of control over its distance attenuation settings. And we're also going to look at new functions that we can use in our scripts to trigger when our audio is played at more specific moments during runtime. On top of these functions, we're going to learn a little bit more about making edits to objects in our scene and how we can make sure that those edits affect all other copies of our object. Now, in order for us to do all of that, we're going to be focusing on these objects that you may have seen scattered throughout the game. These large floating bullets act as temporary power-ups. If a player is able to drive through and collect one of them, the power and size of their shells that they fire from their tank increases. And for this lesson, it is our job to add a sound effect that plays whenever one of the tanks drives over and collects one of these power-ups. Luckily, this is nice and easy to accomplish in Unity, but first we're going to need to understand a few more things about Unity to effectively accomplish this task. The first thing we're going to look at are object prefabs. A prefab is a file type that can be found inside the assets folder and can be created by dragging one of your objects from your scene into the project tab. By making changes to the prefab of an object, those changes are applied to all of the other copies of that object in our game. For example, when the game starts, there are 2 tanks available to control. However, those tanks are just copies of the same file or prefab, which we can see in our project tab if we go into the tanks folder, the completed assets folder, prefabs, and then select the completed tank.prefab file. If we were to make any changes to this object in the inspector tab, those changes would be applied to both of those tanks that each player can control. So in order to ensure that all of our power-up objects play the sound that we want them to, we want to make changes to the prefab of those objects, saving us from having to edit them one by one. Now, in this same folder is the prefab of the power-up object, so let's select it. Now, we could start making some changes to this object right away, but let's quickly click on the Open Prefab button at the top of the inspector. This opens up a new window in the Scene tab that allows us to see the prefab of the object that we're about to edit, as well as the child objects attached to it. Now, by child objects, I'm referring to the objects that you can see underneath the power-up object in the Hierarchy tab. In Unity, you can attach objects to others. The object you attach is referred to as the child, and the object that you attach it to is referred to as the parent. So in our case, the power-up object is the parent of the rotation center object, and the rotation center object is the child of the power-up object. This also means that the shell object is the child of the rotation center object, which is the parent of the shell object. Moving on, let's now look at adding some audio to this prefab. The first thing it will need is an audio source, so let's quickly add one. Now notice how next to the object's name in the Hierarchy tab, a little asterisk has appeared. This simply means that the changes have been made to this prefab but have not been saved. So after you add any new components or make any changes to the public settings of pre-existing components, make sure to save the prefab by pressing Ctrl and S on your PC or Command and S on your Mac. Next, we'll need to pick an audio clip for it to play. Now, underneath this video lesson, you'll find a link to a WAV file which you can download and you can use for this sound. I've already downloaded mine. Once you've downloaded yours, I'd like you to import it into your project in the same way that we did with the Music01 file in Module 1. So let's make our way to the Tanks folder, the Audio Clips folder, and then simply drag it in like that. Once you've imported it, select the power-up object in the Hierarchy tab, and then drag the Collect Power-Up audio clip into the audio source like that. Now, for this sound, we're going to make it 3D. So in the audio source, let's adjust the spatial blend on our source to 3D. Now remember, when working with 3D sounds, it's important to consider where the audio listener component will be, because that will affect the distance attenuation of those 3D sounds. Now in the tanks game, it is attached to a game object called main camera. So if I save my prefab of the power up object and go back to my scene and click on camera rig, the main camera object is actually the child of this camera rig object. If we then scroll down the inspector tab, we can see the audio listener here attached to it. So this means that we're going to be hearing 3D sounds from the perspective of this camera object. If we double click the camera in the hierarchy tab, in the scene tab we'll be brought to its location, which as you can see is high above the rest of the scene. Now we want the panning of the sound to be adjusted to match where on our screen the power up is when it gets collected. However, due to the mechanics of the camera movement and its isometric positioning, it's best that we don't include any volume attenuation alongside the panning. The reason why is because that the camera's position is based on the position of both players of the game, or both tanks. If both tanks are quite far away from each other, which you can see here, then the camera is going to be very far away from both the tanks and the entire scene. So let's say, for example, that in this scenario the red tank was to collect a power-up, they should be able to hear the power-up sound fairly loudly, as they should feel as if they are quite close to the sound. However, if we were to add volume attenuation in this way, the volume of the pickup sound will be brought down quite low because the camera, which has the audio listener attached to it, is far away from it. So whilst we definitely want some panning attenuation, we're going to need to make some changes to adjust volume attenuation. Okay, so let's go back to our power up object prefab to make some changes to it. So on the audio source component, let's open up the 3D sound settings tab at the bottom, and let's set the volume roll-off setting to custom roll-off. Next, let's take the lowest point on the y-axis and let's raise it all the way up to about 1. And so now, no matter how far the camera is from the object, the volume of the sound that is emitted from the power up object won't change, but its pan still will. Let's also make sure that we unmark the play on awake toggle 2, so that the sound isn't heard straight away when our game starts. Okay, so now that our audio source is set up and ready to go, let's take a look at how we'll be triggering our sound. Now we could edit the power up script that already exists on this object and just add a few extra lines of code to trigger our audio to play, but seeing as we're still familiarizing ourselves with C# scripts, I don't want to overwhelm you by having you work around large scripts with lots of lines of code that you don't necessarily understand or recognize just yet. So with that in mind, let's save our prefab and then make our way over to our scripts folder and then the audio folder within it to create a new script. So let's create a new one and we'll call it Power Up Audio. Then let's select the Power Up object in the hierarchy tab, and then we can add this new script as a component. Now all that's left to do is double click on the script in the project tab to open it. Okay, so just like in our last lesson, the first thing we need is a reference to our audio source component so that we can access it. So let's create a private audio source variable and we'll call it source for short. Next, we're going to want to get the audio source that we've attached to our power up object and store that reference to it inside our new variable ready for us to use. So inside the start function, write the name of your new variable and set a new reference to it. Then use the getComponent function and get the audio source we want, just like that. We'll also quickly delete the update function as we won't be needing it for this script. Okay, so now it's time to tell our script when exactly we want our sound to play. Up until now, we've been using the start function to trigger our audio to play on the first frame of the game that the script and the object we've attached it to were both active on. However, now we want to play our sound specifically when our player collects the power-up. To do that, we're going to need the help of a new function, as well as understand a little bit more about how this object actually detects when the player has collected it. So let's quickly save the edits that we've made to our script so far, and then head back into Unity's editor and take another look at the prefab of our power-up object. So let's open up the power-up object prefab one more time and let's take another look at it. You may also be asked to save the prefab because obviously we've changed it by adding our script to it. So if you are, don't forget to save it. Okay, so once you've found the prefab again, we're going to take a look at one of the components that is attached to it. Specifically, we're interested in the sphere collider component. So in order to detect when two objects or more are touching each other, Unity uses collider components. Now, if we scroll down to the bottom of the Inspector tab, click Add Component, and then type the word collider into the search box, we can see all the different types of collider components that Unity provides for us. Each one has slightly different options to adjust, but the main difference between them is the shape of the collider that they'll provide for your object. Now, for example, because we're using the sphere collider on our power-up object, our collider is in the shape of a sphere, which you can see in the scene tab surrounding the mesh of the floating bullet. Now, if another object with its own collider component were to touch this area marked out by the green sphere, Unity will then make sure that the objects collide and prevent them from moving through each other. So most visible objects in this game have a collider component attached to them. For example, the tanks that we can play as both have their own colliders attached, and so do the walls of the buildings and the ground, which prevent the tanks from passing through these objects. Now, whilst the main purpose of colliders is to prevent objects from passing through each other, the other significant purpose of them is to use them as trigger areas. When we turn an area marked out by a collider into a trigger area, instead of preventing things from passing through it, it will let them pass and detect the exact frames in which the object enters the area, stays in the area, and finally leaves the area. When this happens, we can use functions in our code to tell our script to follow our instructions and do stuff for us, just like they would whenever we use the start or update functions. Now, in order to turn a collider component into a trigger area, we simply find our collider component and mark the is trigger toggle on it here. Now, as you can see, ours is already marked, which not only allows this object to know when a tank has entered the area for it to apply the power boost for, it also allows us to trigger our sound to play when this happens. So now that we understand how trigger areas work in Unity, let's head back into our script and check out these new functions that come with them. Now, as I briefly mentioned, there are 3 different new functions that we can use with trigger areas. The first is called onTrigger enter, and it looks like this. Now, whatever instructions we put inside of this function will be performed on the exact frame that another object entered the trigger area. The second function is called onTrigger stay, and it looks like this. This function will perform the instructions that we give it on every frame that an object is within the trigger area for, similar to how the update function runs for more than one frame. And the final function is called onTrigger exit, and it looks like this. This function will be triggered to run on the exact frame that any object fully leaves the trigger area. Now, here's a quick tip for you. If you're ever working on a 2D game in Unity and you want to use one of these functions, make sure to add 2D to the end of their names. So, for example, if Tanks was a 2D game, I'd probably change the onTrigger exit function to the onTrigger exit 2D function, like that. Now, in order to play back our sound effect, we'll only be needing the onTrigger enter function. So let's remove the other 2, like that. So just like we did in our last lesson, let's go ahead and play our sound by writing the name of the variable that is referencing our audio source component, which is source, then following it with the dot operator and the play function with empty brackets and a semicolon. Then let's save our script and test it out in our game. So make your way back into Unity, let the script compile. And if you need to, if you notice an asterisk next to the name of this prefab power up object, don't forget to save it. Then all you need to do is play the game. Okay, so now that we're in the game, all we need to do is drive one of our tanks around until we find a power-up object. Okay, so once you've found one, go ahead and drive into it and see what happens. Hey, excellent, we hear the sound play. Now, not only did we hear it play, but if you collect a power-up that is close to the left or the right side of your screen, you should have noticed the sound was panned to the same side in your audio mix. Now, if we drive around our map a little bit more and collect another power-up, we should also hear the sound play again. Okay, here's one, so let's try one more time. Brilliant, it works perfectly. Now, it might seem as though we've successfully implemented our sound, and we kind of have, but watch what happens if I shoot one of the power-up objects with one of the tanks. We also hear the sound play again. Now, the reason why is because the shells from our tank are also entering the trigger area, causing our on-trigger enter function to play our sound. Now, this is something that we don't really want to happen. We only want to hear that sound play whenever our player drives through the object in order to tell them sonically that they've received the power-up bonus. So we're going to have to go back into our script and tell our code to check specifically for our tank objects before it plays our power-up sound. Okay, so once you've finished testing out your game, head back over to the power-up audio script. Now, first we're going to remove the line of code that we just entered that tells our sound to play. In order to do this, we're going to use a variable that you may have noticed has come with this function, but we haven't yet seen in any of the other functions we've used, such as the start function. And that is the variable that has been included within the brackets next to the name of the function. So before we continue, let's back up a little bit and break down what's going on here. Now, variables declared inside of the brackets of a function like this are referred to as parameters. Now, parameters can get a little bit confusing for beginners to understand, so we're just going to lightly touch on what it is that this one is doing, and then in lesson 4 of this module, we'll learn a bit more about why we might use them, as well as how to use them with functions other than the on-trigger functions. For now, it's only really important to understand that the variables declared in this way will hold data or information that is given to the function itself when it is called, allowing the function to do stuff with that data. Now, when it comes to parameters, we can create parameters of any data type we like for any function that we like. For example, if I wanted to, I could add a variable of the integer data type and call it number next to it, and I've now created a new parameter. But by having one specifically of the collider type, specifically inside a trigger function, Unity will automatically do something quite special for us. Now, deep within Unity's API, when Unity notices that an object with a collider component has entered our area, it's going to not only trigger our on-trigger enter function to perform the instructions that we've given it, but it's also going to store a reference to that collider component inside of this variable. So for example, when a tank enters one of our power-up objects, a reference to the collider component attached to the tank will be stored in this variable here called other. Now, this is similar to the way that we used the getComponent function to get a reference to our audio source component and then store it inside of our audio source variable called source. So now, whenever an object with a collider component attached to it enters our trigger area, a reference to that component is stored within our parameter for us to access information about it from. Quick side note, earlier I mentioned that there were multiple different versions of the collider component. Well, each of those components are made up of their own code written within classes of the same name, just as we learnt about in our previous lesson. Therefore, those classes also act as individual reference data types for each of those components. For example, there's a box collider class, a sphere collider class, and so on. But by using this reference type that is simply called collider, we can store a reference of any collider inside of this variable. Okay, so now that we've got a reference to the collider that entered our trigger area, how do we check to see if the collider that entered was attached to a tank? Well, we use an if statement, which remember will check to see if a condition is met, and if it is, do whatever things that we tell it to do, such as play our sound. So let's write if followed by 2 brackets and then 2 curly brackets to make up a body just like this. Inside the brackets is where we'll use our new collider reference variable, as this is where we want to write the condition we want to check for. So let's start by writing the variable's name, which was other. Now, using a variable of the collider type as a parameter of a trigger function, we can access data about the entire game object that the collider component is attached to. There's a lot of data that we can get, such as an object's name, its tag, which we'll look at more in another lesson, and even its position in the game world. We're after the name of the object that enters the area. So using our collider reference, we want to access the name of the object that the collider component we've found is attached to. To do that, we follow our variable with the dot operator and then write name. We then want to check to see if it matches the name of our tanks. So let's write 2 equals signs next to it. Now, object names are obviously made up of characters, meaning that they are of the string data type, and therefore need to be written inside of quotation marks. But what actually is the name of the tank objects? To find out, let's go back to Unity. Let's make sure we leave the inspection of the power up object prefab by clicking the little tiny arrow in the top left here of the hierarchy tab, and then let's play our game. Now, in the hierarchy tab, you'll notice there's 2 objects called complete tank clone. If we double click on the first one, you can see our attention is brought to the blue tank, and if we double click on the second one, our attention is brought to the red tank. So the name of the prefab for these tanks is called complete tank. Now, the part that says clone in brackets was actually added to their names by Unity. Whenever Unity spawns in copies of a prefab into a game, it adds the word clone to the end of the name to tell us that this is not the original object. Nevertheless, this is the name of the object, and so this is what we want to write inside of our if statement. So back inside of our script and inside of our if statement where we left off, we're going to add 2 quotation marks, and inside of those quotation marks, we are going to write complete tank, and then in brackets, clone, with capital letters at the beginning of each word. It's important to remember that we must write the name of the object that we're after exactly as it was in Unity, so no spelling mistakes and no incorrect capitalization. But with that, whenever an object enters our trigger area now, our script will store a reference to the collider component attached to it, and using that, our if statement will access the name of the object and check to see if it matches complete tank clone. So inside the body of the if statement, let's once again write source.play, just like that. Finally, let's save our script and play our game in Unity to test our script. Okay, so this time, if we drive through a power-up object with one of the tanks, we hear the sound play. Let's quickly do the same with the other tank to make sure that it works for both. Okay, here we go. Yes, perfectly. Finally, let's check the issue that we were having before and see if a shell fired from a tank triggers our sound to play. And as we can see, despite the fact that our shells are entering the area, we don't hear the sound play because the shell's name is not complete tank clone. Before we wrap up this lesson, I have one final tip for you when adding sounds to temporary objects, such as our power-ups. If a game object with an attached audio source is destroyed whilst the audio source is in the middle of playing an audio clip, the sound it plays will be cut off and won't be heard. When we refer to an object as being destroyed, we mean to remove the object from the scene it is in, and thus the game too. Whenever the player collects one of these power-up objects in this game, the object should be destroyed so that resources aren't being used to render and process an object that is no longer needed. However, instead, it simply stops rendering the visuals of the floating bullet so that it looks like the object has been completely destroyed. Then the object waits for 2 seconds, giving our audio source enough time to play our sound. Once those 2 seconds are up, it completely removes itself from the scene, which you'll notice if you keep an eye on the power-up objects in the hierarchy tab as you collect one in the game. And with that, we've finished this lesson. So, we've learned a lot today. We first learned about the 2 main roles of the collider components. We learned how by making the is trigger toggle on one of them true, we can turn them into trigger areas that we can use to check to see if an object has entered it using C# functions. We then use those functions combined with a parameter and an if statement to check any frames in our game in which one of the tank objects enters our area and collects a power-up. So well done for getting through that lesson. Hopefully you've now started to feel more confident telling your audio to play using C#. Once you feel like you completely understand this lesson and have checked out any of the additional resources I provided you with underneath, feel free to head on over to the next lesson.